Any situation where more than one condition must be satisfied at the same time gives rise to simultaneous equations. Let's look at a junior school example. If Mary has read 3 times more books than Alan, and together they have read a total of 40 books, then how many books has each of them read? Neither of the two facts alone are sufficient to solve the problem, but together it is simple. There is in fact no limit to the number of variables which you can solve, provided you have a separate equation and an independent equation for each unknown. In the example given above, there are 2 equations and 2 unknowns. The unknowns, of course, are the number of books that Mary has read and the number of books that Alan has read, and the 2 equations we'll discuss in a moment. Instead of solving algebraically, we could simply represent these 2 conditions graphically. First, the fact that both Mary and Alan have read a total of 40 books gives rise to the equation that A plus M equals 40, or rearranging, M equals minus A plus 40. If we then graph M against A, it looks like this. Then we consider the second equation that simply says that M equals 3A. In other words, Mary has read 3 times as many books as Alan. And the graph of this equation looks like this. Both equations are true, and both lines represent the locus of points describing the numbers of books read by each person. However, it is the intersection of the 2 that determines the unique solution. No single equation gives us an answer to the problem. In exactly the same way, acid-base chemistry gives rise to these problems of simultaneous conditions needing to be satisfied. These conditions may arise from electrical neutrality, conservation of mass, or dissociation equilibria. The fact is that each physical condition must be satisfied always, and this gives rise to multiple simultaneous equations whose solutions determine the values of the analytes, for example, hydrogen ion concentration or pH. You won't need to solve the simultaneous equations in this course, and indeed it becomes impossible to do so manually when the number of equations becomes large. That's why we have computers. What you should get from this course is an understanding of the various physical conditions that must all be satisfied simultaneously in aqueous solutions. Then let the computer do the rest to help you visualize how changing variables influences acid-base behavior.